Welcome back to the deep dive. If you're here with us, it's because you want that knowledge that really, you know, sinks in.
And today we are going deep.
We are. We're diving into the mind of a historical giant, someone you probably know for his poetry, but whose scientific life, it fundamentally challenged the way we look at the universe.
We are talking about Johann Wolfgang von Goethe.
Exactly. When you hear Goethe, you immediately think Faust, right?
Or the sorrows of young Werther. But his scientific side was, it was massive. We're talking geology, anatomy, botany, optics.
And it was all kicked off by a pretty serious illness, wasn't it? Back in 1768.
That's right. And it led him into some strange places, even alchemy, which he called a moral chemistry.
And here's the crucial part. His whole scientific philosophy was completely, diametrically opposed to the mainstream physics of his day.
Think Isaac Newton, the establishment.
Right. And what's wild is how relevant Goethe's ideas are, even when you put them up against modern thinkers like, say, the quantum physicist Werner Heisenberg.
And that's our mission for this deep dive. It's not to label Goethe a failed scientist, which is a tag he gets far too often. It's to really understand his anti-mechanistic way of seeing things. And we're going to show you where recent, very sophisticated research has actually confirmed some of his most counterintuitive claims.
Okay, let's unpack this. And I think we have to start with the greatest intellectual brawl of the 18th century.
The color war.
The color war, Goethe versus Newton.
For centuries, we've all been taught the Newtonian view of color. It's objective.
Right. White light is the source. You pass it through a prism, and it breaks apart.
It decomposes into the rainbow. It's a purely mechanistic description. It's all about quantity.
But Goethe looked at that and thought it was just fundamentally incomplete. It leaves out the most important part.
The observer.
The observer. He totally rejected the idea of just breaking light down into little pieces. He was looking for the observable conditions you need for color to even show up.
And what he found was so simple, but profound.
Yeah.
Color only appears at optical contrasts. You need light and you need dark. It's born at the boundary between them.
So Newton says white light is the source of all color. But Goethe is basically saying,
No. Color is born from the tension, the relationship between light and darkness.
It seems like such an abstract difference, but it led him to this incredible insight. He started, systematically varying these conditions?
He inverted them. He took the light and dark contrasts and just flipped them.
So instead of a narrow slit of light in a dark room,
you'd have a narrow, dark bar in a field of light. And when he passed that through a prism, he discovered this amazing symmetry.
The spectra were complementary.
Perfectly complementary. The colors that appeared when light edged into darkness were the exact inverse of the colors that appeared when darkness edged into light.
Okay, so from a modern physics perspective, what is that symmetry actually telling us? What is it?
Well, what's so fascinating is that these complementary states, they're actually a direct result of the conservation of energy in the optical system. Think of it like this. They arise at the same time, like the energy that gets transmitted through a filter and the energy that gets reflected by it.
They're two halves of one whole process.
Exactly, one whole.
And to really hammer this point home, Goethe proposed this mechanical inversion of Newton's most famous experiment, the experimentum crucis.
Right.
But early attempts to actually do it, they failed over and over. Why was it so hard for other scientists to see what he was seeing?
It was the mindset, the very mechanistic thinking that Goethe was fighting against.
But they were focused on the wrong thing.
Completely. The critics focused on the physical setup. They thought, okay, we'll just invert the apparatus and that'll prove him wrong. But the problem wasn't mechanical.
It was optical.
It was fundamentally optical. They didn't realize that the key element to invert was the optical contrast itself, that light-dark boundary.
So the failure wasn't in Goethe's theory at all.
No, it was in the narrow approach of the experimenters. And that misconception, it lasted well into the 20th century.
Until researchers like Holtzmark and Sellstrom finally figured it out.
They generalized the experiment and proved Goethe's idea of symmetry was fundamentally correct.
And this isn't just, settling some 200-year-old debate.
Yeah.
The sources we looked at show that very recent work by people like Rang and Gris-Bellis has confirmed Goethe's results.
And it goes even further. The symmetry is now confirmed as a general property of all radiation energy. It extends way beyond the colors we can see.
You mean into the rest of the electromagnetic spectrum.
Yep, we're talking ultraviolet, we're talking infrared.
Yeah.
Scientists are now using Goethe's complementary model to talk about new spectral regions, they call them.
Oh.
Ultra-yellow and infracyan.
Okay, hold on. Ultra-yellow and infracyan. Those are some serious physics terms. Can you break that down for us?
Of course. It just means that the spectrum you see from light shining through a slit is perfectly mirrored by the inverse spectrum you get from a dark bar blocking that light.
So they're balanced.
Perfectly. For instance, the ultra-yellow, or UY, region of one spectrum corresponds exactly to the ultraviolet, or UV, region of the other. And the same for infracyan and infrared. It's a perfect symmetry.
So Goethe's insistence that you have to look at the dark just as much as the light.
It's been validated across the entire spectrum. It's a huge confirmation.
But the real break with Newton wasn't just about the optics, was it? It was philosophical.
Oh, deeply. Goethe criticized physicists for always wanting to penetrate through the phenomenon, always digging for some hidden cause underneath.
He called it a kind of scientific restlessness.
He did. He argued that even if they found what he called the phenomenon, the original, the archetypal phenomenon, they'd immediately just try to look past it for something else.
He wanted them to just stop.
Yeah.
To leave these original phenomena in their eternal peace and splendor.
He was saying that the phenomenon itself, if you observe it purely enough, is the explanation. Stop trying to reduce it.
Which brings us right to his own scientific method. This is where it gets really interesting for me. His delicate empiricism.
He just completely rejected the separation of mind and matter. He said, and this is a quote, "My thinking is not separate from objects."
Right, and my perception itself is a thinking, and my thinking a perception.
For him, they weren't two different things. Sensation and thought were just two phases of a single act of knowing.
But if you're trying to perceive and think at the exact same time, how do you stop your own biases, your own feelings, from coloring the observation?
Ah, that's the key. That's where the discipline comes in. He said that to truly study nature, you have to renounce the human yardstick.
What does that mean, the human yardstick?
It means you disregard pleasure, displeasure, whether something helps you or harms you. You have to act as a neutral, seemingly godlike being.
That sounds almost impossible. I mean, how can a botanist look at a beautiful flower and just ignore its beauty or its medicinal properties?
The point wasn't to be cold or emotionless. It was to renounce the ego, the judgment that says, this is pretty or this is useful to me.
You just have to focus on its pure form.
Purely on its form and how it relates to other forms. That way the observer can, in a sense, become one with the object being observed.
And this whole perspective, it fueled his complete rejection of mechanism.
Oh, he hated it. He explicitly rejected atomistic, materialistic, mechanistic approaches. He said they transform living things into dead ones. They kill the inner life.
Because mechanism only cares about quantity. How much? How many?
Exactly. And Goethe insisted that quality and quantity were the two essential poles of existence. You can't have one without the other. If you only measure and dissect, you lose the living whole.
You know, in a world that was just rushing forward with new instruments, microscopes, telescopes, Goethe says something incredibly provocative.
He does. He says that man himself, using his own healthy senses, is the best and most exact scientific instrument possible.
It's a radical statement.
He saw the trend of separating experiments from the human observer, just relying on instruments, as the greatest misfortune of modern science. He was really worried about relying on single, isolated facts.
He said that individual experiments only get their real value when united or combined with other experiments.
Yes, they have to form a series, they have to overlap to show you the inner life of the whole thing. He said errors come from people who take one isolated fact and just build a whole theory on it.
It's like looking at one frame of a movie and thinking you understand the entire plot.
That's a perfect analogy. You have to see the continuity, the transformation.
And that idea of transformation leads us right into his biological work, his morphology.
This is where he really applied that holistic vision.
Right, so if his whole method was about the unity of thinking and seeing, how did that play out when he looked at something as complex as a plant?
It fueled this intense search for a simple unity. It all came to a head during his trip to Italy between 1786 and 1788. That's where he had this huge revelation.
The plants.
The archetypal plant.
The archetypal plant. And you have to be clear, he wasn't looking for a fossil ancestor.
No, this wasn't a physical thing. It was more like a template. A blueprint, an ideal generating pattern. He realized that the organ we are accustomed to call the leaf lies the true proteus, who can hide or reveal himself in all vegetal forms.
Proteus, the Greek sea god, who could change his shape.
That's the one. He's saying the entire plant is really just the leaf, transforming itself.
So from the very first sprout to the flower to the fruit, it's all just variations on a single form.
Exactly. He saw the plant's life as this dynamic rhythm of expansion and contraction. And through that process, the leaf becomes the stem leaves, the sepals, the petals, the stamens.
It's all the same entity, just undergoing metamorphosis.
You can see it so clearly. A stamen is just a contracted petal. A petal is an expanded stamen. It's this beautiful, simple, unifying idea.
And he applied the same method to animals too, didn't he?
He did. He was searching for an anatomical archetype for animals, a pattern that held the potential for all animal forms. It was long before Darwin. And he realized no living thing is just one thing. It's a plurality of living parts working together.
This unified view also let him see nature in terms of these grand polarities.
Yes, this dramatic split in life's developmental paths. You have plants on one side reaching their peak in the rigid, enduring form of a tree.
And on the other side,
you have animals pursuing a diametrically opposite path, which culminates in man, who achieves the highest degree of mobility and freedom.
So both start from a similar, simple state, but their drive to perfect themselves pulls them in opposite directions.
It's an elegant living symmetry. He even tried to find the same kind of unity in geology, trying to reconcile the Plutonists and the Neptunists.
The fire versus water debate over how rocks were formed.
Right. He theorized that basalt was deposited from a vast, universal volcanic sea, a concept that tried to unify both fire and water. Again, it's that same instinct.
Synthesis, not specialization.
Always synthesis.
So let's fast forward. We've got Goethe insisting on uniting the observer and the observed. What happens when modern atomic physics comes along and essentially rejects that unity completely?
The contrast is it's stark. Modern physics gets its incredible power from tracing all the infinite variety we see back to simple mathematical laws.
But to do that, you have to separate the world of the senses, Goethe's world, from your fundamental concepts.
You must. You need that level of abstraction for it to work.
And here's the irony. That separation leads directly to the central crisis of quantum mechanics.
The observer's influence.
The observer comes back.
Exactly. Modern physics reaches a point where it's impossible to neglect the changes produced on the observed object by observation. The experimenter, just by choosing how to measure, decides which parts of nature get determined and which stay blurry.
The subject and object are tangled up again.
But not through delicate empiricism. It's through mathematical necessity. It's a ghost in the machine.
And the physicist Werner Heisenberg, one of the founders of quantum theory, he really articulated the cost of this separation.
He did. He noted that modern science had to forego, in many instances, a more direct contact with nature, to give up on Goethe's holistic vision, all for the sake of complete mathematical clarity.
And he saw it as a kind of destiny.
He concluded it was the destiny of our time to follow to the end of the road along which we have started. He recognized that scientific progress seemed to demand this separation.
But the sources also show how Heisenberg connected this specialized scientific path to the huge ethical questions of the 20th century.
Yes.
He tells this story, a hypothetical conversation, about refusing the Nazi oath back in 1935. It's a really profound moment.
It is. Heisenberg was looking back at the role of the educated class in Germany, and he realized that if he, a man of huge influence, had been prepared to publicly resist,
thousands of others might have followed him.
Thousands would have followed his lead.
So why didn't it happen? What was his conclusion?
He believed that the resistance failed, that the world would have been lost, because the educated class, which includes all these specialized objective scientists, was simply unprepared to resist.
Their focus on their own narrow pursuits had created a mind that was
incredibly
clear in one domain, but
morally fragmented, exposed. The intense focus on mathematical clarity came at the expense of a kind of holistic moral strength in the observer. It's the very separation Goethe warned about, but playing out on a world stage.
It goes right back to Goethe's demand that the observer act as a neutral, seemingly godlike being.
He wasn't talking about being detached in a mathematical sense. He was talking about being morally whole. If the scientist achieves perfect clarity but loses that moral yardstick, the consequences are enormous.
So what does this all mean for us? On the one hand, you have Goethe, the poet-scientist, insisting that true science demands we stay linked to the world we observe, seeking a living, unified picture where thinking is a form of perceiving.
And on the other, you have modern physics, led by brilliant minds like Heisenberg, achieving unimaginable power by deliberately separating the objective from the subjective.
Hmm.
A separation that unlocked the atom, but also exposed this profound ethical vulnerability.
Which brings us to our final provocative thought for you to take away. The source notes mention that Goethe's first spark of scientific curiosity came from alchemy, which was all about finding a reflection of human qualities in nature, a moral chemistry.
So, if modern science demands that we leave the world of our senses behind for mathematical abstraction and intense specialization, does the fate of science, and maybe humanity itself, still hinge on whether we can integrate the moral with the mathematical?
Can science, a field that now thrives on being broken into a million specialized pieces, ever find its way back to that genuinely unified attitude to nature that Goethe valued so much?